So friends, as a part of your curriculum, you would have studied the circuit breaker in your BTech, right?
Yes, sir.
Yes, sir.
Why do we need a circuit breaker?
Sir, as a arc quenching medium.
Now, arc quenching medium is okay.
To break the fault current, and after break we make the contact.
Yes. Why we need to open the fault current?
If the circuit breaker is not break the fault current or not disconnect the faulty part from the main part,
Yes.
the circuit will be totally collapsed.
Yes. Because
So that reason circuit
yes,
breaker is
needed.
uh,
Yes, you're perfectly
needed.
correct. Perfectly correct. You know, because the fault current will be in terms of kiloamps. What you carry is, maybe 2000 amps. But fault current will be in terms of 31K or 40K or 50K. Is just imagine 50 times or 25 times the current flows. So that what kind of destruction it can make? The whole circuit breaker will collapse. It make into pieces. Next is that the circuit breaker is to protect your, it is a protection for transformer. Transformer doesn't have anything. If fault takes place, it has to just feed the fault current and collapse. But the circuit breaker is utilized to protect your valuable equipment like your transformer. Transformer is the heart of your system. So this fault current is not opened, it will damage all the equipments, including the conductor. So the circuit breaker is essential because under abnormal condition, the current flowing into the your circuit will be multiple times. It will be disconnected, right? So that is the reason we have a circuit breaker. So can you tell me what are the different kinds of circuit breaker available?
Air circuit breaker, vacuum circuit breaker, air blast circuit breaker, SF6 circuit breaker,
Very
molded
good.
case circuit breaker, MCB, RCCB, ELCB.
Wonderful, 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 wonderful. Very, very nice. You have covered both LT, low tension, as well as high voltage. You covered MCB, MCCB, all comes under low voltage circuit breakers.
LT side set.
LT circuit breaker. So what happened? When you break the circuit under abnormal condition. Abnormal condition is what? Fault conditions.
Fault condition.
Right? What happens when it breaks the current through a breaker? What happened really? You are making, when you break, what happened? The current will not come just like that zero. It was flowing through a conductor. When you open it, the opening will come as either air. Air is the medium. Air may be between the contact. The contact is closed, and when the contact is open, it creates a opening between two contacts. So the current is try to go through that. It can pass. The current will pass through that, like through arcs. The line got disconnected, na? Is it visible
Yes,
now?
Yes, sir.
no, sir.
Okay.
SF6
I know.
circuit breaker only.
So when it is flowing through air, that energy is also wasted. Energy I squared and R. That this one the arc energy. So it can create lots of things. That energy, it can break the circuit breakers. So what we need to do is, when you open the circuit, you have to take such a way that, the arc striking between the conductor need to be reduced. And the resistance. So current, how do you quench the current? How do you bring the current to zero? Only when the resistance of that arc becomes very high, then the current flowing can be reduced. That's what we do that. Whether it is air circuit breaker or SF6 breaker, vacuum circuit breaker, this is what it does. That arc has quenched quickly. So the energy spent will say reduced. Right? That's what does. And air is an insulation medium, correct? And when you put the air, what happens? The air will elongate the arc. So when you elongate the arc, what happens? The resistance, the path in friends, are you?
Sir, please change the slide, sir. We are at second slide.
Okay. No, yeah, I have not changed it.
Okay,
I
okay.
have not changed it. Yeah, same. I have not changed. So that has to be increased. So that medium is air. Either when you use air to increase the length of this arc, it's called air circuit breaker. When you use medium SF6, this has high insulation capacity. As soon as the contact is open, the insulation, SF6 comes into between the two contact. So this is high resistance medium, high insulation strength medium. So when high insulation medium is introduced between the contact, it becomes small. The resistance is high, the current will come down. So friends, this is what we are going to do that. But SF6 is a green gas. You know that, no? Are you aware?
Yes, sir. Non-toxic.
This will affect your atmosphere, ozone layer. So the handling of SF6 gas, you cannot leave it on the air. Now lots of restrictions are in handling SF6 gas. Right? So they go for vacuum circuit breaker, air blow circuit breaker, some other things. So SF6, for the sake of this one, you read it. But handling SF6 is a very important things because it is a greenhouse gas. Releasing the gas in the air will damage your ozone layer. So lots of restriction in handling SF6 breaker bottles. Right? So all said and done, this is the only difference. So the insulation medium is SF6, sulfur hexafluoride gas, that kind of things. So a circuit breaker is in which a current getting can't operate in sulfur hexafluoride medium is called SF6 circuit breaker. Is excellent insulation property, has high electronegativity. Whenever a free electron collides with the SF6 gas molecule, absorbed by the gas molecules and form negative ions. So this is a medium. So the attachment of electron with the SF6 molecule may occur in two different ways. The negativity ion obviously have heavier than the free electron, and therefore overall mobility of the charged particle in SF6 is much less as compared to the other common gas. Hence, for a heavier and less mobile charged particle SF6 gas, it requires high dielectric strength. It occurs high dielectric strength and arc is quenched. I'll go a little faster. So due to the high dielectric strength and high cooling effect, SF6 is 100 times more effective than air. This is important. Due to this unique property, it is used complete range of medium voltage and high voltage. Circuit breakers are available. The range of is available, but handling the SF6 is a very tricky thing, and it is a very involved one. You cannot handle it just like that because you cannot leave it in the open air. SF6 circuit breaker, what happened? See, this is also circuit breaker. So the testing will also be all tests applicable to any circuit breaker is applicable to SF6 also, whether it is routine test, type test, special test, commissioning test, all are applicable. All the circuit breaker testing are applicable to this one also. Only that, only addition is SF6 gas bottles. Right? That is the only difference. Otherwise, the testing, routine test, and type test, all are similar to are all the circuit breaker. We talk about air blast circuit breaker, SF6 breaker, or vacuum circuit breaker, and all such things. Friends, SF6 circuit breaker consists of fixed and moving contact to enclose a chamber. The chamber, inside the chamber, you have SF6 gas, right? The fixed contact is a hollow cylindrical current carrying contact fitted with an arc horn. The moving contact is also a hollow cylinder with rectangular holes in the sides. The holes permit the SF6 gas to let out through them after flowing along and across the arc. The tip fixed contact, moving contact, and arcing horns are coated with copper, tungsten, arc resistant material. Is costly. Recommended to reclaim using suitable auxiliary system after each operation of the circuit breaker. Right. These are all different kinds of circuit breaker, buffer, single buffer, double buffer. This is what it happens for operating a moving contact. You can able to see now? Friends, you can able to see now?
Yes, sir. Yes, sir.
Yeah. So this is a construction type. See, these are all both contacts. Right? On fixed chamber. This is a moving chamber. And SF6 comes in once opens, it comes into picture. All are closed. Right? All are closed. So when it's open, the gas comes into picture, the arc chamber opens, and this SF6 enters, then increase the resistance, so it get quenched. This you can have a look at it. These are all different type of buffer type SF6. Here the piston is fixed, the cylinder movable. The cylinder is tight, but due to the presence of fixed position SF6 gas inside cylinder is compressed. The compressed SF6 gas flows through the nozzle and over the electric arc in the axial. Due to heat convection and radiation, the arc radius reduces gradually, and the arc is finally extinguished at current zero. That's all we do that. So this is a way to do that. Nozzle, fixed contact, it's a moving contact, it opens, and this SF6 come inside. So it quenches the arc.